My name is Ren. Hi, everybody. Wow, responsive crowd. Thank you, thank you. All right. Evidently, I'm a very friendly person. So after this, you can come and talk to me. We can have a nice discussion, any question at all. But the reason for me, I think you made a quite interesting short introduction. I am originally an architect, practicing with UNStudio for 10 years. But one of the things that somehow in over drinks, people ask me what I do. I felt the urge to describe and explain myself. I was an architect. I'm no longer doing an architect. So in short, over the story, you'll hear a little bit more what I do. I'm head of innovation of strategy and forecasting for an internal think tank called UNS Futures. And from UNS Futures and all the development over the UNStudio, we've created a technology company, and it's called UNSense. And I'm head of design strategy there. And today, I want to share with you a little bit of our diary with technology. And over 30 years of practice from architecture and urban domain, I thought that it's maybe really nice to bring you through what has happened, what do we think, and what do we want to achieve in the future. So therefore, past futures, dear technology. First, the context, very short. We practice in all scales, urban, architecture, infrastructure, product, and interior. You probably have seen this bridge somewhere. We also do in architecture itself, we practice in a lot of typology, from housing to offices to culture, down to product, and also designing small little truffle slicer. But what is interesting, maybe, one of the many questions we've been asking ourselves are these. I heard just now there was a question about speed. There was a speed about technology and everything. Society changed slower, and I think everyone knows here about the Stuart Brand's idea of the change, the layer of speed. And these are the type of questions we also ask ourselves. And Stuart Brand in 1995 actually started from here. Francis Duffy talked about the layer of longevity, and Francis Duffy is an architect. So he was talking about in architecture, you have layers of longevity. The shell is the one that is longest. And then, for example, the second one is the services, is the second layer. And then you have a scenery, which are partitions you can move. And the last one are sets, which are furniture. And I think it's quite interesting how Stuart Brand has turned it around and make it even more deep, even more comprehensive. You have the site, you have the skin and the structure, you have the services, you have the space plan, and you have the stuff inside. And what is interesting here is that he talked about the shearing layer of architecture, because if you think about from a capital cost perspective, you pay a lot of money for the structure, to build the structure, to build the building, and then there's a little bit of a capital investment. But that building lasts for 50 years, let's say. And within this lifespan of 50 years, there are other things that changes. There are services that changes, the space plan that changes. And over time, the cost of the things that changes outweigh the cost of the structure. And therefore, yeah? Yeah. All right. And therefore, he says that the architecture is constantly tearing themselves apart. This is quite interesting as a concept. And I think this becomes even more relevant today when you have a layer of technology coming over into the space. So I will roughly bring through in three phases: past, present, and past futures. I call it past futures because the past futures is a little bit always what we think the future should be. And we're never really there until it happens. So it always stays as an idea, and futures is in plural because it could be many, many forms that can turn out. So the past, from our experience, we have been doing this through design and or predictions. I can give you an example. Arnhem Central Station, this was a design that we started design in 1996, which is over 22 years ago. And during the time, to do a computer edit design using a software was actually quite advanced. So we started this design here in 1996. And then in 2015, it was 19 years of construction, based due to bureaucratic, due to political process, also due to a lot of many things, economic. And in 2015, it's completed. But what I don't want to talk about the architecture itself, but I want to talk about the way we deal with predictions, the way we deal with data. Back in 1995, one of the things we wanted to do was it was actually quite an interesting site. There's a lot of relation happening around the site. For example, there are a lot of different transportation, mode of transportation that comes, and it's a tight site, and it has the train, the taxi, the buses, the trolley, the bikes, the car park. They wanted to put a lot of cars into the basement as well, and they wanted to extend the city towards the back. So there's a prediction of how much the pedestrian will cross. So with this idea, it was very interesting that as an architect, back in the time when there's no real-time data, we had to predict, working with them, what are the relation between them. So from there comes projected data, what it means to us, how do we measure this, how would the space work? And then within the brief itself, it grows into space, and then it has a very complex program. It has offices, it has the station itself, it has also public spaces, and all of these needs to create a different type of relationship. And as an architect, without this, we had to project what it means and what other relationship means. And for example, therefore, we start to create a relation diagram. And over the time of the day, 24 hours, at which point will be people coming through, what will mean, and what are the relationship between all of these complex diagrams. And I want to bring this Christopher Alexander reference. This is done in 1965, and this Christopher Alexander is one of the early ones that influenced software architecture and software development itself. And he was talking about an artwork by Simon Nicholson. And the way he looked at the artwork was that he translated the triangles into relations, and he wanted to understand what are the relations between triangles. And from there, he created a chart on how these are related. And it's quite interesting also to see that he's looking at the relations of relations. And these are before data, we have real-time data. And I think from this understanding, this is how we actually try to find relationships. And so from there, we devised and created the space, projected how the people will flow, how much will it come, what is the projection of the flow of the people. And from there comes the translation and design. The form emerges. And the final result, this is the final result. And one of the ways that we want to gather this was to make sure that over the prediction itself, we want to nudge and influence behavior through natural lighting. So one of the discussion in the design instrument was to use natural light as a natural wayfinding. How can you predict the movement of people, but at the same time use natural element to enhance and nudge people towards that prediction? And because there's a lot of stress related to it, and I think this comes back to the people. We really think that, you know, when you travel, it's stressful enough. How can you allow for space itself to be making traveling much more seamless and easy? And so the space becomes a result of that thinking. And I think I want to demonstrate that in terms of the type of technology that was back then. We did not have real-time data. We did not have a lot of data to begin with. It comes with a prediction. And therefore, skipping many years coming to present, now the discussion is become blurring the boundary between physical and digital space, and also between the process of designing and also the operation where the building starts. And so the process part, one of the tools that we use we use Grasshopper script, but basically to understand relations. As you can see here, this is a floor plan. It's about the floor plate ratio, how much area is going to be there, relation to the ratio of the window, which gives in turn the relation to the daylight into the space. And there is a lot of things in struggle here. Cost per square meter is expensive. Cost for window is expensive, but at which expense? Because the user at the end is more important, that you need to feel that you're comfortable in the space. So we need to find a balance, and the relationship between the data is teased out through these type of methodology. And of course, there are much more complicated systems right now to design that, to understand the relationship. And the other thing is about the tooling itself. The tool for UNStudio, we've always used design software, 3D design software. So for us, this is a basic way of designing. And in fact, what's happening now in the industry is that this becomes the norm. The building information modeling is basically a model of 3D that everyone from all the consultants need to adhere to, and this is where they manage all the complicated systems. So for example, the ducting, all the walls, all the materials, all the structures needs to consolidate into one single model. And this becomes the industry standard. But what is interesting there is that it becomes a digital twin. It starts to become a it's not in a physical way, but it's designed in a way that it becomes, if it's kept in that way, then you have a digital version somewhere else. Your building will become a digital version. And this is also the step where the city buildings are coming. Singapore is one of the pioneers, spending about $80 million to create a digital twin version of Singapore in a software. And they needed to do that for simulation, to communicate to the people, it's political, and many so on and so forth. So this is already slowly happening. And with digital twin, it also means that you can do simulations, what it means, how does your building perform. And this is helping the design, that you design something that performs better. And what we did before, like projection of movement, you have software to do this right now. Software tells you if your space has designed something that creates a congestion spot, a bottleneck. How can you improve that, change it, and do a simulation? But what's happening right now is that it starts to become real time. If you start to have a digital version somewhere and you have sensors that reads real-time information, you are starting to create real-time information. And this is where we're gearing towards. It's getting really interesting, complicated, with a lot of issues that's not really resolved yet. And one of the things is about dependency. And code space basically talks about physical space that starts to rely a lot on digital softwares. And the physical space and digital software becomes very intertwined. And this is starting to happen. All the buildings that all the buildings that you step in has all the systems. They have energy, the lighting, fire, security, water, your ventilation system, elevators, and everything. And these are softwares that are now consolidating. And without the software, you cannot really operate a building. But one of the most interesting one to highlight is, in fact, an airport, basically. An airport is one of the most complicated code space that there is. So you're moving through, is it very stressful? I think you guys have the same stress. You move through this space, there's a lot of things you have to tick, but this is from a user perspective, but as well as from an aviation perspective, the flight, also from the airline perspective. And you start to see from a user's, it actually started already when you book the ticket. All of these information start to merge together. This is a perspective of a user navigating in Schiphol. This is a perspective of an airplane looking at the runway. So there are multiple angles of looking how the building is being used. But if you start to look into the system itself, you start by computer reservation system. When you book, it starts to tell you which flight is available. And then when there's a departure control, when do you check in? Are you checked in? Which seat are you going? Have you crossed security? And then the baggage handling system that manages all your baggage, where your baggage goes, which airplane. There is air traffic control system. There is border control system. This is also very important for immigration and security systems. And all of this is just a few of the systems that I'm talking about. But and we know airport, it's a very, very highly complex building. This is one of the most, this is in Atlanta, this is one of the most used airport in the world. It is the most used airport in the world. For 2017, there was 104 billion people that crossed the airport in a year, on average of about almost 300,000 people per day. So operation of such an airport therefore relies heavily on the system optimizing and improving itself. But what if computer says no? And that happens. So, and this is one of the few cases in Miami, for example, the immigration system shut down. In Sydney as well. So once that happens, it's mayhem. It's not that the plane wasn't there. The plane is sitting there, but you're just stuck in the system. And this whole space, you just can't cross the system. Cross the system. So what is interesting here is, in fact, the implication towards the people. So these are tweaks of people saying that the system got shut down, but then you start to see things like this. The lady next to me is having a breakdown. There's a physical fight going around the corner. Please turn on the air conditioning. Everyone is getting agitated. And the issue here is that these systems trap us as a human being. And I think, therefore, speeding forward to the future a little bit more, and therefore I was asking, we were just talking about how can space become an instrument, working both digital and physical towards the people, and also towards the nature. So one of the few things that is happening right now is that is speeding. It is about understanding and reading physical space. It's all about getting more information about the digital twin. So there are a couple of technology that's happening. Everyone knows about the Amazon Go, which is very, very interesting because they're now talking about the way you shop. You don't really need to go through that system. The system becomes almost ubiquitous, almost to the background. That is so easy and so easy to use. But of course, it failed for many other reasons, economic reasons, and so on. But I'm not going to talk about that because it's very interesting how they cross over the physical and the digital. So if you look at the ceiling of Amazon Go, it's full of these. And they're full of sensors. And these are sensors that are trying to read movement of people. And they're technology using visual recognition that understand what are the people doing, whether the guy's touching something, or this guy's picking up something and standing, eating, scratching head. The system itself is slowly learning, but we know the progression of the technology is going to be really fast. It's already getting so fast right now that AV is going to be able to roll out safely, hopefully, and that relies a lot of computer vision reading the environment around. But what is important is, in fact, redefining the value. It's not just measuring everything for efficiency's sake, but I think we need to redefine what the values are. And this is an interesting project from Professor Dina Katabi from MIT, whereby she's using radio wave she bounces radio wave all around the spaces, and she believes in every physiological effect that you do, it has an effect on the electromagnetic environment. So your breathing, your heart rate, the way you walk and your sleep is all the telltale sign of your health. And she wants to figure out how we can use these to understand ourselves a little bit better. And she's talking about helping to aid for a better habit, better lifestyle, to have an early detection of depression, and so on and so forth, and what you can do. And so the technology she just started a startup, and it's called Emerald. You can check them out. And the system itself reads, as you can even go behind walls, all your movement and everything. And also this one to read your body, your movement of your heart rate, and so on and so forth. And from there, they're talking about quite interestingly, how it could read your emotion. And because that's very important elements that people tend to forget. People just talk about where you walk, how much spaces do you use, and who have you met. But in reality, what is the effect of space and what is your current state? This is quite interesting when you start to understand that. And this is what we want to also bring in to find a relationship between space and the impact of space to the people, because we can no longer ignore the impact of the built environment on human and nature. And this is a responsibility for us to really come in and do something and learn fast and see what it means to adapt. And one of the examples, for example, is health. And this is just about how the factors that contribute to your current state of health. So it starts from age and hereditary features. That's something that you can't really control. And then your lifestyle choices, that you can control, but you could also be nudged through the space. Your social and physical environment. This is something that we kind of, from an architecture and urban planning domain, we can contribute there. Social, political, and cultural environment. Maybe this is a bit too high up. So I think we're operating between this domain. How the space changes your habit, and how does the space itself gives you the environment. And this quote is quite interesting. Many who study population health believe that your zip code is more important than your genetic code in predicting your health outcome. Because there's a lot to do with behavior, it's a lot to do with decision making, it's a lot to do with influences. And if you break them down, this is from a Boston Foundation healthy people. They're seeing how much of the percentage actually contributes to a healthy your health state. So your behavior is 37%, and your environment, whether it's socio-economical or physical environment, is 22%. Adding up is more than 50%. So therefore, how can space help that? How can we as a designer create that? Is it nudging, or actually is actually creating we want to call it returning the agency to the user. We want to give people the reason. First you understand, and then you make a decision. It's no longer just nudging you. So this is an example done by Nat Geo TV, and they wanted to do a test if they can ask people not to take the elevator if you're going up 3 floors. So they start to do that by very gentle in the elevator. For those, there is an elevator on your side. For those who want to take going up to 3 floors, please take the elevator. But it doesn't really happen. But what they found out is the explicit message is the one that works the most. And the intercom just said, for those people who are going to the 3rd floor, don't be lazy. I know who you are. Please go out, get out right now and take the staircase. It's instructive. And apparently that is the best way of getting people to do something. You nudge them out of the comfort zone. So what we do, I mean, this is one of the design that we did for Eni, which is an energy company in Italy. This is related to energy, it's about sustainability. We could, in the end, design a great system. We could project how much energy renewable that we will generate, how much energy we will save. As an idea, you can build that into the system, but that is not enough. The people, the behavior is something that we need to focus on and see how we can change that. So we also try to bring in the digital layer of informing. So much like this, your phone has your, now every end of the week tells you how much of your screen time you have used and how much are used on productivity, entertainment, and social media. It really tells you informs you of your decision, informs you of what has happening. And I think things like this, as the spatial environment, can do the same. So what we did was how to see where can we start to have, as a building, tell the people about the energy consumption. So we also did the idea of course, there's a way of putting this app on the user. The user can actually see how much energy they've been using, how themselves, but also as a building to tell the environment. This is a percentage of energy consumption of energy, how much the building has consumed. And this, it tells you the percentage of how much the energy, the building has produced renewable energy. And I think the idea of creating a building, whether internal or external, that actually magnifies and tells something so that people get an idea of what the implication of their decision. And the last one I want to show you is a project that we did. We were asked by Salone del Mobile, which is the biggest furniture fair, to design something about the future of work. And they say we will have an exhibition. Can you do something about it? And for us to deal with the future of work means that the most pressing point that we have is about stress. So we wanted to deal with stress. So our question was, can a built environment, can a space environment be responsive and be reactive that helps you elevate your stress level? So we asked the question, can a space detect and positively affect your stress level? So it's a prototype. So we work with neuroscientists, we work with technology maker, and really just say what we mean, what can we do. So with the discussion, we decided with the neuroscientist, she was talking about how, first of all, you need to be informed. You need to know what's happening. You need to know where there's your state of stress. Number two, there's different way of dealing with stress. There were 7 pods of design, but in the end, we only did 2, which is active pod and the passive pod. The idea, she was talking about some people way of dealing with stress is through actively exerting force, throwing plates, punching people, punching walls. And the other one is a passive way, which is staying away from people, laying down and calming down. And there's a way of doing stress. So based on that, we created 2 pods and 2 environments. And it has this ECG that reads EEG that reads your brainwave, and then there's a heart rate to read the EEG to read your heart, ACG to read your heart rate. And the idea was to create a base level of your stress. And before someone enters, you get measured. That's your base level, and then you go into the active pod or the passive pod, and then from there you realize that which one works better for you, because at each pod that you go, the reading changes. So this is also quite interesting for people to understand if passive works better for them or active works better for them. So yeah, it has this. It has a personalized feedback. It has wearable sensors. You go in and then you stay there, and then you do something with the space, and the space basically look like this. The active one has because we couldn't buy a lot of plates to break, because it also takes a lot of money and cleaning after that. So what we did was there's a reactive wall, but as well as a electric drum set that you could hear and start to punch and really just exert force. And whereby the passive one reads your heart rate and then projects your heart rate, project a sound that mimics your heart rate. And once it's synced, it forces your heart rate to slow down by slowing down the heart rate that's projected to you. So there are a couple of ways that the environment actually would change your behavior and your condition. Yeah, so that's a reset index. So last slides about futures. Coming back to this slide is it's a very big question for us, because we cannot deny the fact that you can't change the structure very much. The more you understand the space, but in the end, where is your agency as a designer? Where is your agency as an architect to do something? We think that it is actually blurring more and more right now, based on the design. And we think that, for example, this tower was built in 2009. It was a tower built for office. This is in Zuidas, Amsterdam. It was built as an office tower. But because of the recession, probably the looming recession back then, the client asked us if we could think about the transformation of an office into a residential. So that's what we did. We designed the way that from an office floor plate, if needed, it can be turned into a residential. Maybe for non-architects, you think it's quite easy, you just add some walls. It's actually not that case. There's a lot of issues with the elevator. There's a lot of issues with the system and MEP system and so on. And this becomes one of the exercises that we have to design and try it out and see what it means. And of course, it wasn't change. It was just an exercise to see what it means. But I think this kind of structural thinking, this designing for the future, anticipating for the future, embedding a system of transformation, what it needs to come when it happens, what will change and how will it change? Because the relationship that we do right now as an architect, we no longer design something and pass it over and say, thank you very much. We need to be responsible with the building that we built. We want to be able to understand how does the building affect the user in the next 5 to 10 years? And how would the building needs to change in the next 5 to 10 years based on the data set that we understand and we collected? And that is the new relationship we're trying to push forward. And therefore, this becomes one of the very important questions that we're asking and ourselves. And we're trying to answer this by doing. So there's a lot of tests and examples that we do. Systemic transformation. I think I will leave you with that. Thank you very much.